mind that's made of, baby, that's made of all that we find. Test the waters, ooh, it's hot. I think we're getting close. Racing through the waves, I want to be where nobody knows. Take me, baby, take me to a state of mind that's made of, baby, that's made of all that we find. Electric, feel it in your head. Hypnotic, watch your body stand. Happiness, this is what we Are we asleep? Will we wake up? Is this a dream? I wish we could just let love set us free. Will someone please save the world that we're losing? Will someone please?
Hey everyone, we are back again for another stream of going through Advent of Code 2020. Advent of Code is an annual event that happens every December, where there are every day 25 different coding challenges that are released. So we're just going to go through these. We're on day 5 so far. So far we have perfect score. Yesterday, if you saw that, it was a little embarrassing. It got a little cringe. It didn't work out too well for us because we spent way too long on something that was really a one-character issue, right? We're writing in Ruby because Ruby is dope and everyone should know more about Ruby. That's my little advocacy piece here. So let's get into this. And also, I talked to some friends afterwards, and there were some things I think I could have done better with yesterday's. So if we have time at the end, I'm going to go back and revisit and see like some ways we can make that a little nicer, because that switch case was really cringe. We don't want that. That's just no good, right? But anyway, let's get into where we are now, okay? Binary boarding. You board your plane only to discover a new problem. You dropped your boarding pass. You aren't sure which seat is yours, and all of the flight attendants are busy with the flood of people that suddenly made it through passport control. If you remember from last time, we didn't have our passport. It was really an awkward situation. We had a North Pole credential of some sort that had all the information that a passport should have, except the country, because the North Pole is not really a country. It's imaginary. It's just a continent. There's no government there. There's no organization. There's no people there, except Santa, obviously. Santa and his elves. So anyway, after we broke international law by getting on this plane with fraudulent documentation and opening up the gate. What's like a water gate? I feel like there's a word for that, and I'm just like blanking on words, and this is really embarrassing. The floodgates, exactly. The floodgates tumbled down and people poured in as we hacked into their system, another felony, and made it so that people could go in with a dodgy passports. Round one of this, every problem has two parts. For part one, we made it really dodgy so that it just let everyone in. It just checked, hey, do you have all the fields? And later on, we did make it a little better so that we would check to say, hey, are the fields valid or not? So anyway, that's a little bit of the lore that we have here. We're on vacation. We're not saving Christmas, unlike usual. We are not saving Christmas. We're on vacation, but apparently we are very bad planners because we don't have our passport and we lost our boarding pass now. And now there's a ton of people on this plane that should not even be on there because they don't have a valid passport because we opened up the floodgates for them to get through. This is a travesty right here. Hey, Baka, yes, we are back. We are back. We are back flaunting federal and international law getting onto this plane, and hopefully it turns out well for everyone. So where were we? Okay, so you aren't sure which seat is yours. Oh yes, and all these people are flooding in. It's terrible. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, your puzzle input. Perhaps you can find your seat through process of elimination. Instead of zones or groups, is this a link? Oh, I don't want to be DCMA'd, so I'm not going to follow that. This airplane uses binary space partitioning to seat people. A seat might be specified as FBB, some code combination of F, B's, L's, and R's, where F means front, B means back, L means left, R means right. That seems like a terrible system for telling people which seat's theirs. Just saying, just saying. A little advice, I don't know which airline this is, but I feel bad. I feel really bad for screwing you over and letting all these stowaways on, but you need a better numbering system. This is just not really good. Okay, so the first 7 characters will either be F or B. These specify exactly one of the 128 rows. How very convenient, a power of 2, on the plane numbered 0 through 127. Each letter tells you which half of a region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front or in the back. So we're basically doing like a binary search here. The next letter indicates which half of the region is half of that region the seat's in, and so on until you're left with exactly one row. So we're basically doing a binary search of these numbers, it looks like. If you're not familiar with binary searches, the general idea is that you can have a data structure that looks like a tree, right? Actually, maybe I can find like a good graphical representation of this. Search graphic. So something like this here. And when the tree is balanced, basically like things on the left are always smaller, things on the right are always bigger. So you notice how we start with 8 here. If we're looking for like example the number 4, we go left and say, okay, we found the number 3. We want to go bigger than 3, so we have to go right, that's 6, and we go left, that's 4. So that's basically the kind of algorithm we're doing here. Anyway, so the next letter indicates which half of the region the seat's in, so forth. Okay, so that's how we figure out the row. For example, consider FB, FBBB. I'm not reading all that out. So this is basically just describing the process. So front means lower half, so 0. So F means the lower half. Okay, that's good to know. And B means the higher set of numbers that we have available to us. I wonder if we're gonna do like some like recursion for this, because binary trees usually lend themselves really well to recursion, so that might be a good solution here. We'll go further and see what exactly we're doing here, though. The final F keeps the lower of the two. Okay. Okay, so notice how we're cutting in half each time. 0 through 127. It might actually be easier for us if we do a 1 base number and convert it down, just because we're going to be doing integer math. So, for example, if we go 128 and divide by 2, that gives us 64. And then 32 and so on. I don't know. We'll see when we get into it. And then we can just like subtract 1 off at the end, and it's very simple. Okay, the last 3 characters will be either L or R. These specify exactly one of the 8 columns of seats on the plane. So let me actually visualize that for a second. 8 seats. So is it just like, oh god, this sounds terrible. So is it basically like 1, 2, 3, 4, then you have the aisle 1, 2, 3, 4? I would hate to be on this plane. I guess it could also be. It could be like a layout like this, I guess, where you have 3 and 2, maybe. Or I don't fly around that much. Are there planes that kind of like have this sort of pattern here? I have one too many here. Let's get rid of this. That just like the 222 sounds reasonable, but I've only been on planes. Maybe I just haven't been on like international flights or whatever. So I've only been on planes that are kind of like this, 3 and 3. That just, and I know that there are ones where it's like kind of like I've seen 2, 3, 3, 2, 3, 2. Oh, that's really interesting. It's like the idea of like being in like a 4 stack sounds like the worst experience ever. I would not be okay with that. I would definitely want to get on a different plane for sure. Anyway, that's not really all that relevant to what we're doing here. The last 3 characters will be LR. Okay, so we're just doing a binary search on the left and right ends of this, right? And are we doing it? Okay, and we're doing a numbered column again, 0 to 7. For example, consider the last 3 characters. Yeah, I don't think we need to actually go through this because we get the idea. We start with 0 through 7. R means it's 4 through 7. L means it's 4 through 7. The halfway point is 4 and 5. R means that you're on 5. Okay, that's easy enough. 4 stack, get me off that plane. Yeah, 100%. I don't feel super comfortable. I refuse to even do like middle seat on a plane on like a 3 stack, right? That's, oh god, that especially like if it's like for an hour, maybe I would do it like a middle seat in a 3 stack. But other than that, no, god, that I get super claustrophobic. So just being on a plane is just really really quite a sight to see. So being in the middle and not really having anywhere to kind of like lean out of, like either lean against a wall or lean off the edge. Oh god, that I would not be happy there. So every seat also has a unique seat ID. Multiply the row by 8, then add the column. Okay, that all makes sense. Plus COVID these days. Yeah, I mean, I think probably from what I've heard from people who actually have been flying, airplanes are pretty desolate nowadays, so it's not a huge issue. Like, planes are actually pretty safe in that regard. I don't know. I don't know if I would trust it, though. Also, there's nowhere I actually want to go during COVID, because I like going to cities and hanging out with eating out places, you know, and seeing the people and everything, and you can't do that. I'm not one for like just like going to the Grand Canyon and looking at like a big hole. That's not really all that interesting. I mean, that would probably be pretty cool, but like generally, like I'm not into the wilderness, and that's kind of like I think that's the only like recreational travel you can do right now. Planes are perfect super spreaders. Yeah, you're probably right. You do have that that cabin air that's kind of like just stuck in there. Yeah, I don't know. I don't know, but if there's like only like 2 people in the plane, that's fine, right? I don't know. I don't know. The airline industry is ruined right now. I think we can all agree on that. So just coding, this long code I'm not going to read out reveals that the seed is row 44, column 5. Okay, that makes sense. Closing people for a while so the virus can spread, then releasing the people into different places. Yes, exactly. That's like really bad. So watch out for any planes coming from Florida, you know, just oh god. Imagine like a plane coming from like Florida to like Nebraska, poor unassuming Nebraska with like 5 people, or Utah. Utah's a better example. There's no people there, but they'll all get COVID once one plane from Florida lands there. I feel like Utah probably doesn't have an airport though, right? Why am I saying Utah? I mean Wyoming. Wyoming's the state that's unnaturally square and has no people. Uh, Utah has people. Okay, so we're gonna do this calculation, figure out the seed, and let me just keep. So the rows are the first set of the FBs, and we're multiplying that by 8. Okay, that makes sense. So it's kind of like a bit field there because yeah, it's exactly a bit field because there's exactly 8 seats. So by multiplying it by 8, we're basically pushing it over. I got a lot of family in Wyoming. Confirm they have airports. They are small though. Yeah, so they're just like baby spreaders. They're not super spreaders then, right? There are some other boarding passes. Here's some other boarding passes. So we can actually use this as a test suite to validate that what we're doing is reasonable and that we're not just Oh, you guys can't hear the music at all, so let me turn that up a little bit. I feel like the granularity is it's a very thin line where I'm either blasting it to you or not. I just noticed that the green bar was not moving at all, so what's the point of spamming chat with like all of these we are licensed to play the song if you're not even hearing the song. How embarrassing. Close that window. Okay. So we have like a little bit of a test suite here that we can make if we want to. Okay, let's make a new folder and get into this. Day 05. Let's just take a peek at what our puzzle input's gonna look like. I do not want to translate the puzzle input. No, I do not want that to be Welsh. Or I guess does one of these actually end up being like a valid Welsh word? I don't know. I know nothing about Welsh outside of it. I think that the Prydain Chronicles by Lord Alexander. I think that he borrowed from Welsh for a lot of the words that he made up and the names he used and stuff like that because he was very impressed by the mythology that they have over there. I guess I don't know. Okay, so we're basically dealing with like a really like a normal sort of input like last time. So we're gonna copy over from last time. We're gonna copy over our day 4 in problem 1. And delete most of it. Oh no, I actually did that terribly wrong. I need to do this. We can just do a dot here, right? Yeah. Perfect. Here we have day 5, problem 1. Most of this we're throwing out, but we're going to hold on to our input lines because that is the trooper here. That is the trooper that will see us through these harsh times that we live in. So we're going to just save our input, replace the old file. We have a copy of the file now. I need a copy of the directory though. Drag that guy in here. Perfect. Okay, so we have a lot of to work with here. So I guess the first part, it's actually kind of the parsing of here is really simple, just because we're dealing with fixed lengths here. Let's make a little. Okay, we don't need passport valid anymore. That can go away. Line to hash. We'll probably be modifying this a bit, and probably making a different name, so we don't actually need this. We keep our skeleton of main and main. And I guess maybe we just like kind of like start off with just making this a method so that it's a little easier for us later, right? Seat from line. And let's just, as a test, before we even get into reading in the input, we can just use we can use this right here. Seat from line, and this will be our line initially. Perfect. Let's open up our IRB real quick. There is one point, I always get paranoid about using array syntax on strings, because at one point, if you used array syntax in Ruby, it would return the character code as an integer, rather than the actual character. So even though this has not been an issue in probably about 10 years, I'm always very paranoid. I'm like, okay, let me just make sure this still works the way I think it should work. It's an odd tick I have. Okay, so the first, how long is the initial? The first 7 characters, right? Okay, that makes sense. So let's just say we're always starting off. Just say that we're starting off max row. I think the math is going to be a little easier if we do 1 base instead of 0 base for now. Max call is 8. Min call is 1. And we're just going to subtract 1 off when we actually have to do the math on it. Just because we're going to be doing integer division. No, I don't want any hints. We're just going to... Thank you for offering, though. I'm just going into this blind and just working through this. If we get later in and you notice I made a stupid typo that's going to take me like an hour to figure out, though, then I'm all for that at that point. Okay, so we can just we're going through this. We're going through it 7 times. We don't actually care about the index, but we'll hold on to that anyway. And we can do line. The character is... That was nice of Fog. You know, you never know. Some people just like to pop in with spoilers and you get sad about it. Oh, actually, we do need the index. We do need the index here. I don't know why I said that I didn't need the index. I definitely need that. And just as a paranoia here, 7 times array. Yeah, so that starts with 0 to 6 there. Okay. I'll explain my solution after you're done then. I think it was pretty clever. Awesome. Yeah, you know, I'm all about seeing other solutions to these problems after I go through them. I know that one of my friends, we were talking through the solutions last night. It's fun. It's fun. I think I might actually go back to my day 4 and modify mine a little bit because I did it a little bit of an awkward way that wasn't super nice. Okay, so we have the current character, and we're just going to trust that the input is correct here. char equals, and the two options are F and B, right? Right, so here. So if it's in the front, that means we're looking at which side of it? Yeah, I think you'll want to see what I did for today too. Glenn, knowing you, I feel like I'm gonna have like a 100-line program here, and you're gonna have it like in Julia written in like 5 lines, and I'm gonna just feel really bad about myself. That's what's gonna happen. And yeah, Baka, definitely commenting is very valuable for sure. I don't think that I've done anything that's not trivial yet so far, though, so I'm not too concerned about that. So let me remember here. Is front high or low? Front is low. Okay. So every time we do front, we're just gonna chop max row in half. And every time... yeah, my part 1 ended up and 2 ended up being a total of 12 lines in closure. Okay, that's totally fair. I think it was 37 or so for Glenn. Okay. Closure is pretty handholdy though, so I don't take a lot of pride in it. I actually don't know. Closure has always been like on my list of like maybe one day I should look into this, just because I feel like I've been in the same languages for a very long time, so it would just be kind of like interesting to break out of that. So if it's not F, we're gonna just increase this. Actually, if we just trust that the format's good, we don't actually need to enumerate a certain number of times, do we? No, I don't think we do. We can just blaze through then. This takes a bit to wrap your mind around, if it's something new. Yeah, I looked at Lisp a little bit back when I was in college, back when I was basically every week trying to learn a new language every week, every few months or whatever. And Lisp, and the two that like always, the three that always got me in trouble. Lisp, I couldn't get my mind around that. OCaml was pretty similar, I thought, and I never really got my mind around that one either. And then, what was the other one? Erlang was the other one that was very popular for about 5 minutes. That just like everything I do involves string handling, and its string handling was such garbage that it was like, this is way more effort than this needs to be. Erlang is really cool though, from an implementation point of view. How like you can do hot reloads and stuff like that. It's really cool in that part. The runtime is really cool, but the language is just like, you can tell it was written when phones were first invented. Okay, so instead of doing like an explicit 7 times, let's actually be a little more. Let's just iterate over the entire string. Each do. Character. So we can get rid of this and this. And then we can just continue this. REPL in any language is really cool. I kind of like, I feel really sad whenever I'm forced to use a language that doesn't have a REPL. For a while, I was writing Ruby a lot, and then suddenly I had to write C#, and the lack of REPL there just... it was a very painful adjustment. Like, just in addition to transitioning to, like, a very different kind of language in terms of the metaphors that they like to have as first-class concepts. Okay, so let's look at the left and right. So we're going to do a similar logic here, I think. If it's on the left, we cut down the max down, right? Yeah, I think that's right. Range columns. Right means the upper range, yeah, so. Yeah, we're just gonna cut this off here. I keep on looking back at the instructions because I'm a little scared that I'm doing the logic backwards. But that's fine. That's why we're doing like a little test case real quick to make sure that I'm not like crazy. In row times equals 2. This doesn't seem right. No. The times equal doesn't seem right. Because initially the min is 1, so yeah, this is actually all wrong. Now that I'm thinking through this, because initially it's gonna be 1, so like if we're saying left first, and it's also wrong for B also. Like for example, if we are starting with like 128, we want lower bound to get up to 64 or maybe 63. We do want it to get to 64, looking at the instructions. That makes sense. It's taking a minute to think through how I want to approach this. It's actually kind of interesting. My first iteration of this problem, I did the way you're doing it. Yeah, this just seems very wrong. Yeah. Maybe it's more of a matter of like, you have the concept of the length of the thing that you're looking at. It sounds like it's more complicated than it needs to be, but let's just run with this for a little bit. So let's say that row length is 128. And then after that, we want, let's say that we want the row length to be, the row length always becomes 64. Upper to be, and we want the range to be 64 to 128. If it's L instead, it's still 64, and we want the range to become 1 to 64. Or actually, I did this wrong. It's actually front and back. The same logic's going to apply, so once we figure it out for this half, we're going to figure it out for the other half as well. We're just using different numbers. That means take the upper. Okay. And actually, I flipped these. It doesn't really matter. It doesn't matter, but I did flip these accidentally. Right, because back is 64 to 1. So if it's the upper half, I want to move the lower bounds up by half of the length. So really what I care about is the length. So I can still track back and front, but I do need to also track the length, because that's how much it's not a simple division. We're doing addition on like the on the length here. So when we're looking at the back, we're doing max row minus min row divided by 2. I think that's what we want here. And then we do something similar for max row here. So in the front, max row, we substitute off half of it. Okay, this makes a lot more sense here. And so for L, let me just be very careful. I feel like I'm gonna flip the L and R and the F and B a million times here. R means high numbers, R means high numbers, so we're increasing the min. So this was actually correct here. Min row plus equals, okay, so we're doing, oh, that's actually wrong all along, because also we're doing column here. Let's make Baka happy. Let's add a comment here. Add min higher half. Yeah. Subtract half for max. I think I actually have these backwards. I think that's accurate, right? Best coder in the East and West? Oh man, you're too kind. You're too kind. If I was best coder in the East and West, I would have already solved this. Okay, so we're actually doing like a lot slower than we normally do here, because we haven't even run this once yet. So let's just run this and see what happens. We're not really using row length yet, so let's comment that out. It might be nicer to actually store that instead of... Oh, and we're still doing the wrong thing here. Max call minus equals. Left we take off. Right we add on. Front. Front we take off. Back we add on. Okay, okay. Let's just run this and probably hit some sort of syntax error because I forgot some variable or something, or I start off with a variable as one name and moved it to something else. That was not what I expected. No, I'm actually not returning anything, so that actually makes a whole lot of sense, right? So let's return instead. We'll do at the end of this, max call and min call and max row and min row should all be the same, right? Because we limited it down. Just make this pretty here. Min row, max row. This is a sanity check to make sure I'm not doing things completely wrong, because I may have done things completely wrong. This is a reality that we need to deal with here. Max call. So we're gonna do this, and we're gonna inspect this so it's pretty printed. Actually, let's just do PP on this because that will make it pretty printed. Oh, that's interesting. We didn't actually land on the same number for each of these, so one of these is off by 1, right? So let's look at our example and see what this should have been. This should have been 7 and 7. Okay, so the min is the one that we always want here, I think. Let's substitute in a different number and just see how that works. So if it's the min this time, and it's right, then we're on the right path. Oh, we're off by 1. We're off by 1 with our row. And our column is very wrong. Okay, so we obviously just have some very bad logic for our column there. You are right. I am starting with numbers that are off by 1. I thought that, like, with the division, it would kind of, like, work out in the end. But actually, yeah, that's a good point. Let's just adjust these. And see how these all look. Actually, we can just load up all of the test cases here, so we don't need to be repeatedly changing them. This is kind of like our test suite before we get into the input. FFBBB, FRR. Okay, we did that right. BB, FF, BB, FR, LL. Okay, let's hit it again. Okay, so in this case, max was good for the first one, and for the second one. We're not consistently always ending up at 7. That's what I was kind of worried about. So on the last case, we did end up on 4, which is correct. Oh, wait, and also it is supposed to be column 7. I misread that last time. So max is correct there. So it's max for the first one, and it's min for the second one. And then for the third one, it's max again. We're doing something wrong here. We're doing something wrong here because the middle one is not correct. Let's take a look at this in a debugger and just kind of like let's walk through this and see what the algorithm's actually doing that we don't want it to be doing. Let's make this area bigger so that we can see what's going on. We're dealing with our first F. And let's have repeatedly be showing max row, min row. That's a weird order for that, right? Min row, max row. Okay, so we would expect this to become 0 and 64, right? No, it should be 63. So it's kind of like a non-inclusive. So maybe it's just like -1 if it's F. That does make sense. Let's do that. Because it's kind of like a non-inclusive thing there. Continue. We're just gonna burn through this. We're gonna get rid of our binding pry. We're gonna get back in here. Let's see what the answers are now. This one. 15, 18. This is still not looking good for us. Oh wait, we're looking at the call. We didn't do it for the No, we did this for the row. We didn't do it for the call. Let's get back in here and see what exactly is going on. In row, max row. It's already equal, so wouldn't it be +1? Well, the thing was, when we ran this the first time, when you do half, you want to go from 0 to 63, right? Just by looking at the instructions they have here, and we ended up with 0 through 64, so that's why I added the -1. Oh, but we're already doing a minus. We're doing minus equals. Oh, that makes a whole lot of sense. We were going in the opposite direction. So it's like the whole thing is wrapped up in a negative. That makes a whole lot of sense. That's 5 head right there. Okay, let's get rid of this, and we'll just run through this again. No binding pry this time. Let's just see what this looks like. Oh, and let's do the same thing down here also. Because I think that's going to be important there too. They match in the top one, not the bottom one, but they match in the top one. That's really good. It's not right though, because it's 14. But it's really good that min and max match, because they really should, right? That's very confusing for me that they didn't. If we do all of these again, let's turn these all on and see if what the answers end up looking like. And do I still have my binding pry? Because I'm not gonna hit each of those again. I don't want to do that. Yeah, we're good. Okay, so we're getting worse here. This was not what we were looking for. So we are matching, so that's good. But we're not going in the direction we want. We're off by 2 on our first use case, and I think we were better before. And now we're off by 1 here, and we're off by 2 here. Does Ruby truncate or round on int division? Ruby does a floor on int division. So a truncate. But I mean, like in this case, like it has to be integer math, right? Because you can't have half a seat. That's not real life. I think I'm gonna add a little bit of a few debugging statements, just so rather than stepping through, we can actually see what's going on. Yeah, let me bang on my head a little bit. We're gonna get there. Changing max from let's be a little more succinct here. Old min row. We're just saving these variables so that we have them preserved for the debugging statement. Row. Old min row. Min row. Let's go. Old max call. Min call. L changing. Yeah, we're on max. Sure. One more time so we can see what's going on. At this point, I've already wished that I've put this like halving logic into a method, and that might be what we do next. Okay, so we're in front of the plane. So now it's 0 to 63, that's right. Because this is the same example, right? The first one... Actually, let's match the example exactly here. So we can just like follow along with the logic and make sure that we're not doing anything really, really weird. Plus, looking at multiple of these at the same time is going to get really weird, right? Okay, so following the logic. Okay, so we changed this to 63. Changing min row. To 31. That's not right. This should be moved to 32, so we're off by 1 here as well. And this one can be a +1. So let's run this again. Because we're not doing like the weird minus equals. Yeah, you know, it's always off by 1 issues, right? Okay, so are we correct here? Okay, so we're right on 44. That sounds good. Okay, let's look at some of these other examples and make sure that we're doing the right thing. Okay, we're matching here. That's good. Okay, we didn't make the adjustment to column, so column is still going to be weird, right? +1. That should actually fix this, I think. Okay, we're matching everywhere here. That's really, really good. We're 70 and 7. That's good. Let's comment out these debugging lines because I think we've figured this out. Perfect, perfect. And we'll bring these guys back into the fold. Okay, so we're 14 and 7. Okay. We're 102 and 4. Okay, this is actually perfect. Okay, so now we just need to make the unique seed ID, which is by taking the column and we multiply it by 8, and then we add on... We're making like a little bit field there. So let's instead... Min or max doesn't matter because these are always going to be the same now, because we're not rife with off by 1 problems. So let's do... It's the row times 8 plus min call. So this... If we run this now, we should have 567, 119, and 820. Perfect, perfect. So now all we need to do is take this and do this on aggregate over the entire input file, which we already have. We already have this guy right here, which is going to make it really trivial to iterate over these. This will just go through each line. It removes any new lines or anything, so our input's going to look... it's just going to be the input strings that we need. Cool, 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 cool. Love it when things start falling into place here. Let's go up into our main, and we can just loop over the lines here. We do need to do something here. We need to figure out what is the highest seat ID on a boarding pass. Okay, that's easy enough. So we can just do max on that. So we're going to do map because we're transforming this array into something else. We're just going to call each individual line a line. Seat from line. We are returning the integer. So this is another case where I'm IB. That's not it, right? Where I'm trying to remember what is in Ruby core and what's in active record. Okay, so max is actually part of of Ruby core, so we don't need to worry about implementing that part. Well, I had a feeling that that was going to be the case. I feel like every time I go to reach for an array method, I'm always like, okay, is this something that active support added on? Because Rails added so much stuff, it's actually insane. Okay, so let's see what the max is here. Oh, we did something terrible here. Oh, we didn't even. Oh God, this is rookie time here, right? Seat from line. We gotta pass in the line, or else it's not gonna work at all. Oh, and I never printed it out, so. 991. Okay, so do we feel lucky? Do we just throw this guy in, or do we hit submit and see if we move on to the next part, and hopefully we don't end up in the timeout of shame? I think we go for this. I think we passed our test suite. I think we just rip it and rip it. Let's go. There we go. Another star. Moving along. That's right. We got one gold star closer to saving our vacation. Perfect. Let's see what they have for us next. Always lucky. Always lucky. Except for yesterday. Yesterday we were not lucky. Ding. The fasten seatbelt signs have turned on. Time to find our seat. It's a completely full flight, so your seat should be the only missing boarding pass in your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 or -1 from yours will be in your list. So what does this mean exactly? There's some seats that don't exist. That's totally fair. The seats with IDs +1 and -1 from yours will be in our list. Okay. Taking me a minute to just like parse exactly what they're asking for us here. So things that we do know. Our seat wasn't in the very front of the aircraft. I think seat IDs with low numbers like 1, 2, 3 aren't necessarily in the input. Okay, that totally makes sense. And also really high numbers are also not going to be in the input. Because the very back seat isn't going to be there, right? So I'm thinking immediately of ways that are like super inefficient to do this. I feel like there has to be a clever solution though. Because the oh yeah, I never looked at the sorted numbers. That's totally fair. We can actually do that real fast. Let's copy this over into problem 2. We can just actually sort this. I keep on accidentally ending up with the enumerables when I end up with this rather than actual arrays, so I'm throwing the 2A to be paranoid. Sorted seats. Let's do preprint instead of just inspect here, and let's see what this turns up. I hope that wasn't a hint. Oh no, that wasn't a hint. I was actually probably gonna look at the numbers anyway. Now we could technically like just be like really dumb and be like, oh, this number is missing, because we know that there's a number missing that's kind of like off by 1 here. Seats with IDs +1 and -1 errors will be on the list. Okay, so what we can do is we have the sort of seats already, so we could just iterate through and see if and keep like a memo of what the last seat was, and we can exit out as soon as we see a seat that isn't adjacent to ours. Let's just see what that ends up looking like, right? Okay, so let's just say that last seat's -1, and we're gonna like ignore that if it's not really a thing. Current seat equals seat from line, so we're just getting. Actually, let's work on this sort of list of seats. Actually, because I think that's going to make this a little nicer. Yeah, it's actually necessary for the approach I'm thinking of. So we're going through each seat. We're going to say that. Let's actually set the initial seat to nil, just to be a little cleaner. So we're going to keep a memo of last seat. Okay, so at the very end, we're going to do last seat equals seat. Actually, let's just actually make this like -1, because I don't want to deal with a nil exception. We're going to end up with like a false positive here, I think, but that doesn't matter. So let's say seat if seat -1 not equals last seat. We're just going to write out went from last seat to seat. You know how like when you look at a word repeatedly over time, it starts looking like not a real word? I'm starting to have that with seat, because I actually just was like, S-E-A-T, that can't possibly be the right way to spell seat, right? Like, it just looks weird now, right? We've written out seat too many times for this to be a reasonable thing to be looking at. Okay, let's not print out the sorted seats anymore, because that's going to make this really impossible to look at. And I think we can get rid of the TA to array. It's called semantic satiation. Is that how you pronounce that? That's interesting. I didn't know. I knew it was a phenomena, but I did not know there was like a name for it. So that's really cool. Okay, so this is actually like really easy, right? So 533 jumped to 535. Like technically we can do like a +1 check also, but yeah, no, this is just it, right? It's our seat has to be 534. This is. Let's just like look at the entire list again. We can look at the entire list again and just to look at the list and see like where that happened. 534. Let's go. A bit of sanity here. 530s. 533, 534. No 534. This has to be it. Since I'm actually talking to people that have done this before, is every input randomized, or do we all have the same input? Because I was actually wondering this the other day. Okay. Oh, yours is different. That's awesome. I'm really glad that they make it random. Okay, so we're just gonna hit enter, and I don't think we're gonna be in timeout hell. I think we're just gonna get through this. There we go. We solved today's. That's awesome. Cool, 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 cool. Okay, so we're up to 10 stars. We're making good progress. I did want to double back and look at day 4 because there was. Can I send a paste bin for mine? Absolutely. Yeah, we'll take a look at it right now. Okay, let's take a look at this. So what language is this? Clojure. Okay, okay. So I haven't written Clojure, so this is going to be a little wonky. I know that the basics of like how Lispy languages generally work. They don't have a syntax. Instead, they just go off of parens. The crux is that you don't need to do a binary search. Oh, that's really interesting. You can replace FRBL with ones and zeros? Really? Then just convert the binary to base 10. That's actually... That makes sense because this whole thing is a bit field. Oh, wow. Wow, that makes a whole lot of sense. For example, that becomes and 101, which are 44 and 5 in binary. Yeah, that makes perfect sense. That. Oh, wow, that's really interesting. So yeah, so. So if you have this and you replace all the F's. So front, back, back, front, and then 101. That makes sense. Okay. And then that just translates into literally the thing we talked about. Because we talked about earlier how... how do I get back into the problem? Return to my advent calendar. We talked earlier about how like this part is basically doing a bit shift operation because it's... there are 8 slots that we're talking. There are 7 slots we're talking about. So if you multiply a number by 8, that's basically the same as bit shifting it over that many. That's really cool, guys. Man, that would have been a much shorter stream if we figured that part out. That's really clever, though. That makes sense that there is like kind of like a really fast solution because I know that people like will get through these like really fast if they're trying to compete on time. Did they have a similar problem to this in previous years, or I'm not like really familiar with all of the problems that they have that they've done over time? Because I know that coding challenges often like there are only so many problems in the world, so like at a certain point they always have some similar qualities. That makes sense. That makes a whole lot of sense. Let's see how... I wonder how short this would have been if I took that approach. Let's do... alt problem. It's not even problem anything, but yeah. Probably see something with Manhattan distance in the next couple days. I'm not familiar with Manhattan distance, so I'm going to have to do a little research on that probably. That's really interesting. So seats from line smart. I think we can just do G sub F is 0. B is 1. R is 1. And then L is 0. And I think that this takes a base argument. So like let's just check this out. A and in space 10 that's going to be an error. Oh, wow, it just like oh right, if it doesn't recognize something it'll just convert it into like it'll throw out garbage characters. Okay. So what we can do is just from here do I do this is a bit shorter than this. L is 0. Oh, I had them reversed. Okay. Or actually, no, I just had them wrong. So what logic? Let's I want to have logic that's more similar to problem 1 because I don't want to see like the whole list of things. We're just testing to see what this looks like. Let's just have this line for our main for this one. Seat from line. We're going to make it smart. And we're just going to return afterwards because I don't want to have to clean that up quite yet. I did something wrong here. Seats from line. That's why I called it. What are you talking about? Seats from line, plural. Why did I pluralize that? That's very, very weird. So for this one, the F... B, where was this one? $357. Yeah, it worked perfectly. That'll give you garbage because RL and FB need to be split. I mean, it gave us the correct answer, though. Yeah. Yeah, because it's all a bit field, right? Because we took the first part and we multiplied it by 8, so it's literally just bit shifting. Yeah. That's really cool. Oh man, that's actually like really, really smart. I love that. Thank you so much for sharing that solution. That was so much nicer than this guy that we made here. And much less error prone. Oh, that's funny because I was not even close to guessing, oh yeah, you just turn them into 1s and 0s and it's fine, and it just like automatically works out. But I did pick up on that we're essentially making a bit field. So that's really funny that it's just like that one last leap. Thank you so much for not spoiling that because that would have been much less fun. It's all about challenging your brain a little bit. So this was more fun for me, being able to go through both of these. Oh man, that's just really cool. That's just a really clean, elegant solution to that. I love that. Yeah. Okay, so we are through with today's challenge. So this is actually where I'm going to end the stream today. We'll be back tomorrow, hopefully. After this, I'm actually replacing a hard drive that I've been working on for the past like 12 hours, and hopefully that's actually going to work out for me. So if you don't see me tomorrow, that's because something terrible happened. Something terrible went wrong. Down at the bottom, I have links for YouTube, for Twitch, not for Twitch. We're already on Twitch. I have links for Discord that will ping when we go live,
want to hang out again. And on Twitter, I occasionally post notifications when I go live as well. So, hey, Fog the Catman, thank you for following. I really appreciate it. Hope to see you all again soon. This was a fun stream. It was nice hanging out with all of you. Have a great day. I hope you guys have a great Saturday.